So for section 7.4, we're going to be doing adding and subtracting rational expressions. We're going to go ahead and start with just kind of the rules, but the idea is if we are adding fractions with a common denominator, then we just add the numerators and we keep the denominator. That should be a review skill, but we're going to be doing that with much more complex fractions in this course than you did in previous courses. What do I do if the denominators aren't the same? Well, the issue here is that they have to be the same size pieces for you to add them, so that means they need the same denominator. So get them a common denominator. Generally, it's whatever the least common denominator is. If there's nothing in common, we'll multiply them by each other. But once you do that, then you will multiply the top, and we'll combine those numerators, but we will keep the denominator again the same. So we will actually have to multiply and combine the numerators. We're not going to leave it as a big multiplication problem. We want to combine any like terms. And always, don't forget, always simplify if possible. Okay? So let's go ahead and start with an easy example, and we'll start kicking it up a notch. 7/18 plus 9/18. Well, they have the same denominator, so straight across, add the parts, 7 and 9, about 16 over 18. Well, that can be simplified. 16 and 18 are both divisible by, looks like 2, to give us 8 over 9. Well, this one looks a little more intimidating, but it still has the same denominator, which means the pieces are the same size, and we can add the numerators. So I'm thinking of this as a common denominator of x squared minus 1, and then I'm going to look for some like terms. For instance, x squared and 4x squared can add together, giving us, and then I have, it looks like 6x minus x, how about plus 5x? This is not done, so you keep in mind, this, I've added the numerators, but it can be simplified. You have to check if that top can be factored. Well, 5x squared plus 5x, it's not a trinomial, but don't forget, they have a common denominator of 5x, leaving us with x plus 1 all over, look at the bottom. See, if I just put the x squared minus 1, we'd say, no, that doesn't cancel anything out. Well, check, can that factor? That is a special a squared minus b squared, x and x, plus 1 minus 1. Now I can cancel out, not the x and the x and the 1 with the 1, but the group with the group, leaving us with 5x over x minus 1. Can we cancel these x's? I hope you know by now that is no. We only cancel across multiplication, not adding and subtracting, only multiplication and division. So the reason I could cancel this was we had all these groups multiplying, cancel the group with the group. This 5 times x, that x doesn't cancel with this x minus 1. What if I had 5/6 plus 4/15? Well, we cannot add those the way they are. Now I could multiply the 6 and the 15 and make that 90, but there's an easier way. See, if I look at the 15 and go, well, 15, 6 doesn't go into that, but 15 could become 15, 30, 45. Basically list multiples of that larger number and stop when you find something 6 goes into. Now I could keep going, 60, 90. There's a lot of other factors, but the least common denominator, the least common multiple of these two would be 30. So that would be this 6 times 5 and this 15 times 2. In this situation, it's not going to make a big difference. At the end, if you don't do this, you'll have to do a lot more simplifying than we will. When I get to these complex, kind of where I'm adding the, I don't know, with integers and with variables and with, well, then you really want to give these the least common denominator, or you're going to make your life way harder. So once again, now we have a common denominator. 25 and 8 is 33 over 30. 33 and 30 are both divisible by 3, giving us 11 over 10. These do not have a common denominator. do not just multiply this first one by a minus 4 and the second one by a squared minus 16. If you do that top and bottom, you will have a common denominator, but there's an easier way. See, a squared minus 16 can factor. That is a minus 4 and a plus 4. So if I'm giving these a common denominator, they both already have an a minus 4. I don't need to do that. They both already have that. What the second one needs is it needs an a plus 4. So you make them the same by only giving it what it needs, not all this extra junk. Just multiply and give it the a plus 4. And if I do that to the bottom, we will also do that to the top. So the way that I would write this now is that we have a common denominator of a minus 4, a plus 4. I'm going to keep that factor in case anything simplifies at the end. On the top, we are going to now treat it as one big fraction with 3a squared minus 2a squared minus 8a. That was this distributing to those two. Combining the like terms, we end up with a squared minus 8a So on the top, now can this be simplified? You need to check. That top, now that we've combined all the like terms, check and see if that factors a, leaving us with a minus 8, and a minus 4, and a plus 4. And I would leave it like that. See, and technically this answer was fine too, because nothing simplified. But do check and see if that factors, because if something did simplify, then that first one would not be correct. We didn't really do anything more to it, so I would accept either of these, but just check. Check the factoring, check if it simplifies, check it at the end. Okay. These do not have a common denominator. For the love of God, do not multiply these by each other. You will make something that is way harder, and the factor at the end, oh, it's a disaster. So say, well, what is z squared minus 8z plus 15? Well, how about z and z? Two things that multiply to 15 combine to make 8. To make a negative 8, they'd have to both be negative. This, z and z, what multiplies to make 10 combines to make 3, how about 5 and 2? To make it a negative 3, a minus 5, and a plus 2. So when I go to give these a common denominator, they already have this z minus 5 in common. So what the least common denominator here is going to be is what they have in common times everything they don't. Everything they have in common times everything that they don't have in common. Or I'll just say not common. Okay, so really what I do, and another way of thinking about this is I go, what does the first one need? Well, it has a z minus 3, z minus 5. To make these the same, it's going to need a z plus 2. Can I just put that down there? Well, sort of. I can do it as long as we do it to the bottom and to the top. This one has the z minus 5, the z plus 2. What does it need? Well, it needs from the other group, it needs a z minus 3. Okay, so what are we going to do now? Well, we have this big, scary common denominator of, and I don't really care the order, I guess I'll do z minus 5, z minus 3, and z plus 2. And each of these had both those parts. What do I do on the top? Well, since we're going to want to combine these, we are actually going to distribute them all out and combine like terms. So this becomes 4z squared plus 8z. This becomes z times z, z squared, minus 3z plus 3z minus 9. If you see that those are out in the middle already, go ahead. So what are we left with? How about, I missed a plus sign there. How about, let's see, 4z squared plus another z squared, 5z squared, 8z, minus 9. Are we all done? Maybe. We have to check, does this factor on the top? Well, this would be an AC, so let's go ahead and see. 5 times negative 9. Something that multiplies to make 45 combines to make 8. 1 and 45, nope. 2, 3 and 15, nope. 4, 5 and 9, 6, 7. See, and maybe if you don't like this, you could just do all of these. What do we say? 3 and 15, 5 and 9, 6, 7, 8, 9. We hit everything. I'm looking for an 8 in there. Not happening. So this is not factorable, which means it can't be simplified, which means we're done. Okay, so this is it. We're just going to kind of practice with a couple more examples, but that's the big idea. If they have a common denominator, add them, simplify. If they don't, add them, simplify after you give them a common denominator. These do not have a common denominator. It is very tempting just to multiply them by each other. Here's the issue on this one. This is a y minus 1. This is almost a y minus 1. Why don't we put these in order and see if it makes a little more sense? Y squared minus 6, y minus 1, plus negative 5 over negative y plus 1. These are not the same, but they're almost the same, aren't they? If that first y could just be positive and the 1 be negative, we can do that. I can make them both change signs by factoring out a negative 1. So I'm looking at what now? Y squared minus 6, y minus 1, plus negative 5 over, factor out the negative 1, leaves us with y minus 1. What can I do with that negative 1? Well, I can divide it into the negative 5. So now we have y squared minus 6 over y minus 1 plus a positive 5 over y minus 1. That becomes y squared, negative 6 plus 5 is minus 1 over y minus 1. This is not y. You do not just cancel these and leave us with a y. The only way we can cancel is cross multiplying. And how do we do that? We check if this can factor. Can y squared minus 1 factored? Yes. How about y plus 1? Y minus 1? Can y minus 1 factor? No. But it doesn't matter. We have a group with a group, leaving us with, and that's how we would put that answer. If you did multiply those by each other, you would eventually get here. You would just have a much bigger mess to deal with as we went on. Here's the good news. These have a common denominator. This does not become x minus 6, though. See, the issue here is that I'm subtracting this entire group. So what I would encourage you to do is give it the common denominator we have here, do 3x minus 1, and then distribute the negative to make that a minus 2x and a plus 5. Now when I combine my like terms, looks like we're left with, how about x plus 4 over x plus 2? Can those x's cancel? Can anything factor? Then we're done. 2 more. We're almost done with this. Do these have a common denominator? No. Do not just multiply them by each other. Okay? So here's what I'm going to do. This is x squared. It cannot be factored. This x cubed minus x squared can be factored. They have a common factor of, so what does that do? Well, now I can look at the left and go, well, look, they both have an x squared. What does it need? It needs an x minus 1 to have a common denominator. If I do it to the bottom, do it to the top. So now we have a common denominator of x squared times x minus 1. On the top, we are going to distribute and add, so 3x squared minus 3x. This negative, just like we did last time, will distribute to make it minus 5x minus 1. So how about 3x squared minus 8x minus 1? All done? I don't know. We got to check. Can that factor? AC again. 3 times 1 is 3. Multiples of 3 that combine to make 8. I think we're done. And last but not least, these again are not common denominators. I hope I left some space for this one. This one looks kind of stinky because of the factoring mostly. Looking there at the top, this is an AC. 2 times 4 is 8. Negative 8. Factors of 8 that combine to make 7. How about 1 and 8? If the 8 were positive and the 1 were negative. So this becomes 2x squared minus 1 plus 8 minus 4. Lost the x there. So 2x squared minus 1x plus 8x minus 4. First two have an x in common, leaving us with 2x minus 1. The next two have a 4 in common, leaving us with 2x minus 1. So all in common is 2x minus 1 times x plus 4. What a mess, but that is the denominator factored. Second one I'm going to guess is a little easier. Let's call it x and x. What multiplies to make 12 combines to make 7. How about 4 and 3? So they already have something in common, so I don't need to multiply them by each other. I just need to give each one what it needs. What does the first one need? Well, it doesn't have an x plus 3. Give it the x plus 3, bottom and top of the fraction. The second one has these two, but it needs the 2x minus 1. Bottom and top. I'll encourage you right now, we're about to distribute this 9. Can we treat that like a negative 9? Minus 9 and then distribute it. It's going to make our lives a little easier. So, our common denominator is now 2x minus 1, x plus 4, x plus 3. On the top, 3x plus 9, minus 9 times 2. How about minus 18x plus 9? So what does this become? 3 minus 18. How about negative 15x plus 18? Just circle it? No. Check if the top can factor. 15 and 8 are both divisible by 3 when the leading coefficient is negative. We're going to factor out a negative 3, leaving us with positive 5x minus 6. But unfortunately, that does not match any of our groups on the bottom. So, we are done. Nothing simplified, so we're done, which means to me these are equivalent. They're going to want you to still check it, but on the test I would accept either because it really didn't change. Okay? So I know that's a lot, but it really shouldn't be anything new, just applying it to some harder concepts. We're almost done. You're over halfway done with this chapter, so keep it up.